Welcome to the CAD Office training series for F.Connect for Open Bridge Modeler. My name is Steve Tischer and I'm a structural engineer with Atkins Realis. In this video, we'll be covering exercise 5.4 from the Bridge Design 3D Modeling and Plans course guide. This exercise demonstrates how to create a custom parametric cell for a skewed end bent. Let's get started. During the exercise, we're going to go over all the components of the custom parametric cell that's in the F.dot workspace. This includes the cap, pedestals, MSE wall lugs, back wall, cheek wall, and the rectangular piles. All right, so to start off in this exercise, we're going to go into our structures folder we've been working in our work set, bridge templates, parametric cells, and then we're just going to make a copy of this F.dot substructure parametric templates, and this is my copy here. Once you open that up, then you'll probably see a message something like this that says this file is not part of a work set. Do you want to open this up in the active work set? And I'm just going to say open. And once the file's open, you want to make sure you're in the NBent MSCLR model. There is another model in here for a hammerhead with a rotated cap, but we're going to use this NBent MSCLR file here first. Once we're in here, we're going to go ahead and update some of the variables that are controlling the dimensions of these different elements in here. The quickest way to get to that is the space bar to activate the pop-up menu. Now, once I do that, then I can click on this little variable button right here. That'll bring up my variables. And then I'm going to expand the local variables here. And we'll start off with the general. Now you can expand this down here and then go one by one, or if you just keep it selected like the folder itself here, you can just change all those variables over here. So the 4 foot is what we want to use for this, 40 foot, 5 inches. The skew angle here, that's good, that's what I want to have in there. False, true for the left side wraparound MSE wall and right side wraparound MSE wall. So the way this particular example is going to work is that the left side is not a wraparound MSE wall. It actually is going to continue along to a twin structure on the left here. But the right side is by itself, so it is a wraparound MSE wall there. So I'm going to set that to true, and that'll affect the geometry in here. Barrier wall width left and right, 1'6" and 1'1" respectively. Just go ahead and follow all these other dimensions in here. And the only other thing that we're going to go ahead and update in here is the pile length. We'll change that pile length to 105. And then moving on to the cap tab, we can come in here and we want to make sure we have the 3'6", 2'6", and then this cap slope left is going to be the 1.587, and then same thing for the cap slope right, the 1.587. And then just leave all these other variables here the same the way they are. And then the cheek wall, that's going to be 9-inch cheek wall, or sorry, 9-inch width to the right. Cheek wall width left, 1 foot. And all these other dimensions in here are good except for the height. We'll go ahead and change the height here to 7 foot and 7 foot. And then moving on to back wall. We want a 1 foot thick back wall. Again, length is always going to be up and down station. Width is always kind of left to right or transverse. And height or depth is going to be in the Z direction, kind of vertical direction. But all these other variables are going to be good here for me, what I want. So that looks good. When you're done entering the inputs, your NBent should look like what is shown on the screen here. Let's go ahead and minimize this. Now note, some of the pieces of the NBent will need to be moved into place manually, like those MSE wall lugs, the beam seats, otherwise known as pedestals, and the pile themselves. The reason for that too is when we're doing these parametric cells, you want to try to limit the amount of things that are kind of constrained and tied to each other. It can kind of bog down the cell if we have too much tied together to each other. And something like these elements over here, these are pretty easy to move into place and pretty easy to merge with the main elements over here. So the first thing we're going to do is going to rotate into a right isometric view. So I click on that rotate view, go with the right isometric view here so we kind of see what we're working with a little bit better. And then we're going to use the copy command and copy the longitudinal direction MSE wall lugs into their position under the cap. And one thing to note is there's not a left lug in our example here. But I'm just going to go ahead and take one of these MSE wall lugs here and then just do a copy command. And we'll snap from the front points of the lug here, and snap them and put them right in place here. Now the next thing we want to do is adjust this lug length here so that it's the same length as the back of this cap here. Easiest way to do that is to select the lug element itself, select the solid extrusion icon here, and then you can just kind of left click on this arrow and then drag this arrow wherever you want it to, or snap to wherever you want it to. In my case here, I'm just going to snap right to the back side of this cap. And then just left click to exit that command. And then now that we got that one in there, we're going to go ahead and place our vertical lug in place. So I'm just going to select one of these guys here, do a copy command, and I'll snap to this corner here. And let's snap to the top part of this back wall here, just like that. Now that's really the only modifications or things we need to do to the cap elements themselves. Now we can go ahead and switch to modeling workflow and go to the solids tab. And then we can use that unite button. A couple things we want to make sure that we're doing is we want to hide the originals. We do not want to see those. And then also make sure you have the merge parametric solids unchecked. We do not want this button to be checked. What it ends up doing is it messes with some of the relationships with the predefined elements, and so we don't want to do that. We'll keep that one unchecked here. And at this point, I just need to select all the elements of this cap here that I want to merge together or unite together. So I can just drag select all the different pieces, hold control, and then left click on the different pieces as well. That also works. And then you can tell I have everything selected here because everything turns that pink magenta color. And then all I need to do is left click to accept. And we can see that it's all kind of merged into one solid piece here now. Now I'm going to switch to a top view. Easiest way to do that is going to be do a shift, right click, T for top. And that'll switch you to a plan view. And so the next thing we're going to do is rotate some of these elements here that we need to rotate so that's the same rotation or skew as kind of this cap here. And those things we're going to do are going to be the pile and the pedestals here. So I'm just going to drag select these. And actually, before I even do that, what I can do is I can check my angle that I need to rotate them by going to my variables again and going to the general. And I can just copy this, right? This is the angle that I'm using for my parametric cell. I might as well use this since that's the exact angle that I need to rotate by. So I'll just drag select those elements there. Quick keyboard shortcut for rotate is QR. And I'm going to paste that angle in there and make sure it's the negative of that angle. So we need to go the opposite direction. We can do about element center, and then also make sure that it's set to active angle here. And I can kind of get a preview of what that's going to look like. That looks good. That's the right direction I need. So I'm just going to left click to accept that. And those look good. And now I'm going to go ahead and first position my pile relative to where it needs to be on the end bend here. And we're going to be snapping to some elements in the corners here. So easiest thing to do to not snap to the wrong element or these guidelines here is to turn those off. Now these are just kind of guidelines that represent the copings, the left and right copings of the deck to help you see where this end bend's going to line up relative to that, because that's typically where we're going to line it up against. But I'll turn that off here for now. And then kind of zoom in. We'll start on this left side here. So I'm going to come back over here to my first pile and just do another keyboard command of copy, which is QE. I'm going to snap to the midpoint of this pile here. And we'll just first move him over here and snap to this point right here. And then we'll do a move command and move him 4 foot in from that point here. So easiest way to do that is going to snap to that midpoint line here. And if I want to get to the right direction with my AccuDraw compass, I can actually hit R and then E on the keyboard and then select the element I want to rotate that compass to. So I'll just select the front face of this cap. And then now it's oriented about that cap. I can hit enter in the keyboard to lock in that axis and then just type in 4 to move that pile 4 foot over from that point. And then next we're going to move this pile so that it's 1.9 foot from the center of the pile to the front face of this cap here. So we use a similar kind of technique Just do a Q, W for move command. I'm going to snap to the center point of this pile line here and hit R, E, left click to snap and rotate that AccuDot compass to this element here. I'll hit enter on the keyboard to lock in this, and then I'll first start off by moving it to the front face of the cap, and then I'll kind of go back now 1'9", so 1.75 feet. Left click to accept, and that's it for that pile there. Now we can go ahead and copy the rest of the pile over. So I'm going to select that and do a QE for copy. And I want 4 copies of this pile. And we're going to move it on the direction of the end bent, the skew direction, 9 foot 10 inches. So go ahead and left click on the pile. Again, R, E to rotate that AccuDot compass to the front face of the cap. Hit enter on your keyboard to lock in this direction and type in 9.10. Left click to accept. And now we have all of our pile for our end bents located in the XY coordinates in the correct spot. Now go to an elevation view to get these pile in their correct spot elevation wise. So I'll just do a shift right click F for front to get to a front view. So once we're in this elevation view, we're going to go ahead and move this pile down, and we're going to make it relative to the bottom of the cap. We want 1 foot embedment of this pile in the high side here. So we'll go and select the pile, do a QW for move command, and we'll select the corner on the high side of the pile here. Hit enter to lock in that AccuDot compass. Move it straight down. You can go ahead and left click to move it to the initial spot, and then go ahead and say 1 foot, type in 1 foot with that AccuDot compass still locked in there to get it up in this position here. And we'll go ahead and do the same thing for the rest of the pile as well. And one trick you can do too is if you don't want to have to move it down here and then move it again, when you're in the middle of this first move command, you can actually just kind of hover over this bottom point here and type on the keyboard minus to bring up your pop-up calculator, and you can just say 1 foot. And what that does is that basically moves the pile to the point where I'm hovered over, but it subtracts a foot from that distance. So that's actually the perfect distance that I need. That's the 1 foot from the bottom of the cap here. And then go and do the same thing for the rest of those pile. And that's it. So now all those pile are in the correct spot on elevation wise. And now that we're done with those pile, we're going to go and focus our attention back to the beam seat. So I'm going to go back to an isometric view. That's probably the easiest way to view these beam seats and what we're going to do here. Just a normal isometric view here. And these beam seats are going to have a taper on the bottom of them already, but we're going to go ahead and need to remove that taper so that we can apply correct one relative to the position of the beam seat itself. So you can just select the beam seat here and go to your properties, and then this taper face number 2 here, you can go ahead and just right click on that and say delete feature. And then that'll get rid of the taper that's on the bottom of that for now. And the reason we're doing that is because that taper was initially set relative to the orientation of the pedestal, which was not the way that it's relative now to the cap, right? Because we rotated these pedestals after the fact, and that taper was applied before the rotation, so that taper direction was not in the correct direction, and that's why we had to do that. So now that we know that, we can go ahead and go to that Solids tab and click on the Taper Face tool. We're going to choose the Design X, and under the variables, we're going to assign a variable to this, and this is going to be cap slope angle left bottom. Cap slope angle left bottom, this angle right here. Click OK. And then we're going to go ahead and select the beam seat. We're going to select the face. Well, now we really need to get the bottom face, but as long as we're selected anywhere inside where that bottom face is, we can always right click to toggle through the face selection. So I'll left click one time in here, and it's highlighting the top face. I don't want to apply it to the top face. I want to do the bottom face. So I'm going to right click one time to get the bottom face selected. Now I'm just kind of toggling through my element selection basically. And then I want to zoom in and I want to snap to the corner of that pedestal right here. Left click to accept that. Now I'm going to go and place this pedestal here. I'm going to go to a top view, shift right click T for top. And I'm just going to select that pedestal and do copy. And I'll copy right from the corner of it right here. And we'll just snap it over to the corner of the back wall kink here to start off with. And then from there, we're going to go switch to a front view, shift right click F for front. We need to get that pedestal in the right spot elevation wise. And we can go ahead and we already have that pedestal selected. So we can do a QW for move and snap from a corner point. Enter to lock in that AccuDot compass in the vertical direction here. And all we need to do is zoom in and snap to the top of the cap there. And now that's going to be in the correct position vertically and horizontally. And then we'll switch back to the top view here to go ahead and make the copies of those pedestals. Pretty much the same thing as the pile. Beams are over each pile in this case here. So I'm going to do a QB for copy, and we can go ahead and select the center of that pedestal there. Hit R, E on the keyboard. Left click on that cap to orientate the AccuDot compass to the cap. Hit enter. And I want 4 copies of this at the same distance, which is going to be the 9.10, 9'10". Left click to accept. And those are all positioned exactly where we need them to now. Now we have to go back to that front view and check to see if we need to do any kind of tweaking of the elevation view, but how we rotated them and how we moved them and copied them was perfect. So that actually works out well for us. That all looks perfect. Now, if we wanted to go ahead and modify these, right, because these beam sheets are more likely not going to be all the same height of each one. So what we can do for that is actually do a modify solid. And we're not going to do that because we're not going to get into doing each individual beam seat like that. But what we can do is go to that solids tab and click modify solid, and then you click on modify face. And then you can actually push and pull this face up as much as you want. So I'm going to click on the element, click on the face, and then I can move this thing up or down. So what you could do to start off with is maybe measure the one side that you know, measure it up here like this and say, okay, that's 4 3/4. I need to get that to 5 inches, and then you can basically pull that face up 1/4 of an inch to get it to where you need it to be. And now that we're done with the modifications to the parametric end bend cell here, we need to turn it into a cell itself. Right now it's still just like a DGN, it's still just a model. So we need to turn it into a cell. And the first thing I always do is turn off anything I don't want to see in the cell when I'm placing that. So I'll go back to the top view to kind of make it easier to see things. And I don't want to see these guidelines here, so we can go ahead and turn those off. Easiest way to turn these kind of levels off is always right click and hold. And you'll either see a turn level off by element, or maybe it'll say level off. Either one of these works fine. And then you can just click on that element that has the line you want to turn off there. In my case, looks like I have it probably set as a default, which I don't want. So I'll just make another one like end bend cap default by double clicking on it here. And you can kind of see it's turned that kind of dark green or turquoise green here. And then now I can uncheck that clip drawing boundary DP level to turn that off there. So now I'm going to go ahead and go to the content tab. And this is where some of my cell tools are at. So what we can do is say define origin. Click on that guy first there. And then kind of zoom in, and you can try to hover over that origin point where you want it to go, but it's hard to do that. So what we can do actually is just type this stuff in your manual. So we'll do 0, 0, 0. So type in 0 in the X, enter, and then 0 in the Y, enter, and 0 in the Z, enter. And I see that all these X, Y, and Z's are blue. So that means that those are kind of locked in like that. So what I can do is just hit enter one more time. And then exit the command, right click or click the element selection. Now I can see that origin, that cell origin is placed correctly at the 0, 0, 0 points. That's right where I want it. So now the next step is to go ahead and create the cell itself. So what we can do is open up the cell library, which is going to be this drop down right here under the cell. And we can go just do like a file new. And what we can do is we can just call this underbar tr-pc and go and click save. Now with that custom library saved, what we can do is actually select all the elements that we want to be included in this cell. So I'm going to drag select just these elements here. Then we can click on the create cell button. So I'm going to click on the drop down again there and click on this create. Now as far as the name, just call this one underbar tr-nbent 3-pc. Make sure we select parametric. That's important. And this is all we really need in here. The description, we could put the description there, but we'll leave it blank for now. And I'm going to go ahead and hit create. Now, a lot of times it looks like it's happening again here now, probably. For some reason, when you do this action of creating a cell like this, it crashes OBM. So this is kind of known, expected, but it does successfully create the cell before it crashes. So all we have to do is close it down and open it back up, and we'll see it in there. So we'll go ahead and do just that. We'll just go ahead and get rid of OBM, let it close, let it crash. And go ahead and open it back up. And then we're going to open up the cell that we just created. So we'll go right into that cell itself. Now you might notice we see like the elements themselves are kind of white on a default level here. Sometimes that'll happen. So what we can do is we can just go ahead and reset that to the correct level symbology that we need it to be. The easiest way to do that is going to be to come in here to the element templates and just change them in here. So substructure concrete, end bend cap concrete for that one. And then same thing for these guys. These will be the pedestals. So let's hold control, select all those. Change those to the pedestals, so beam seats. And then lastly, but not least, to do the pile. And then if we rotate around here, can I still see some little bit of a white here? Now this is just going to be the outline of the templates, or the 2D profiles that we have built into the template itself. So for these, what we can do is we can just go ahead and put these on like a construction level, a DD construction. So I'm going to select all these ones we have here. It looks like that has them all selected here. Then I'll just change those. I don't need to do that with an element template, but I can do that through the level symbology in here. So I'll just put that on like a DD construction level. That way we can turn that off and it doesn't print with anything. All right, so now that we have that done, we can go ahead and go back to the OpenBridge modeler workflow, and we need to tag some of these elements. We need to let OBM know what's a cap, what's a pile, and so on and so forth. So for that, what we can do is we can go to utilities, and we can go to assign tag. And then I'm going to go ahead and start off with cap. I'm a tag element. I'm going to select that element there, and then left click to accept. And the next thing I'm going to tag is the pile. Tag each one of these. Hold control. Left click on each one. Left click to accept. And then really if we wanted to, I guess we could use the cap probably for these beam seats as well. So I'll just do the same thing, hold control and select each one of these beam seats. And left click to accept. And so there are limitations with the use of this parametric cell. So as of right now, in this version 2023, does not generate any of the 2D decor levels that we're used to seeing, like the out-of-the-box OBM tool create. And it also will not report the quantities for it, although that will be changing in the near future. And the last thing I'm gonna do is go ahead and turn off that DD construction level that I have in there. So I'll just activate NVent Cap Concrete, turn off that DD construction, and then just do Control F to save settings. And that's it for this exercise.